Hello, and welcome to another edition of AppSec Decoded, where we talk about building trust into software. I'm Taylor Armerding, security advocate with the Synopsys Software Integrity Group, and I'm joined today by two of our experts, Sammy Migues and Tim Mackey, to talk about some of the major trends we've seen in cybersecurity this year. Sammy is principal scientist with Synopsys and has been a co-author of the Building Security in Maturity Model report, better known as BSIMM, since it began in 2008. The latest BSIMM 12 was released in September. Tim is principal security strategist within the Synopsys Cybersecurity Research Center, which also has its own acronym, CyRC. He has a wide range of software security expertise, but his primary focus is open source software, which makes up the large majority of every code base developed in recent years. Welcome, gentlemen, and thanks for being here. And so let's jump right in with software supply chain security. The importance of software supply chain security isn't new because supply chain attacks aren't new. Experts have warned about them for years, but it's more recently that the software supply chain versus hardware supply chain has become a mainstream topic. That's likely due to recent high-profile and highly disruptive attacks, including Colonial Pipeline and SolarWinds. That increased awareness has trickled all the way up to the White House. Supply chain security is a major focus of President Biden's executive order on cybersecurity, released in May. And just this past week, there were multiple stories in the tech press about supply chain attacks launched by Lazarus, a North Korean APT group, and a group that Microsoft is calling Nobelium, the Russian foreign intelligence group that was behind the SolarWinds breach. So, Tim, starting with you, why is the software supply chain such an inviting target for hackers?
So there's really kind of two reasons behind that. The first and kind of the most important is reach. So if I can go and target an application that is distributed to, say, thousands of individuals, maybe millions of individuals, and somehow have my code inserted in it, but have the trust of the brand of that particular application, allowing it to get past whatever gateways and controls might be in place, and that's a huge win for me. So if I can go and compromise a banking app, or I can go and put a piece of software that runs on every single server out there and use it to scoop up data, then I win. I've got control over something. Even if I don't necessarily have the ability to, say, encrypt it, as you might find within a ransomware world, I have control over some aspect of what's in there. And if I do that at the source code level, where it's coming from a library that some third-party author, maybe an open source developer, had created ages ago and maybe might not be maintained today, hey, maybe I can get away with this for a really long time and nobody will notice because nobody's going to go and patch the thing that was abandoned in the first place. So it's all about reach.
Sammy, what activities should organizations consider to manage the security of their software supply chain proactively instead of reactively?
That's a long list. And you know what? Lots of pieces of that list haven't changed in 50 years. Computer security basics, network security basics. Once we invented networks, open source basics. Once we started sharing the software, all the basics are still, in my opinion, where a lot of things are falling down. It's one thing to take in software that probably has malware in it, but even if it doesn't, if I put it on hosts with bad configuration, I put it in networks with bad configuration, I put it in identity and access management configurations with bad configuration, I put it in containers with bad configuration, I put it on clouds with bad shared responsibility models, then a lot of my highfalutin stuff, I scan with all these tools and I have these rigorous econometric models for risk management, and then I deploy it on Windows XP. Okay, cool, thanks for playing. And so in a lot of cases, the types of activities are things we've always known how to do. We just now need to do them to the pathways for which these pieces of software enter our organization. So what's one of the really big activities we need to do to proactively manage the security of the software supply chain? We need to figure out all the ways software comes into our organization. First party code that we write, second party code, bespoke code that we contract for, third party code that we bring in to our source code repository maybe, third party code that we bring in during the build cycle, maybe during dependency analysis or other thing, third party code that we build in, that we bring in when we're creating or packaging production code, and it pulls in, oh, winatoaster.com, oh, hackme.com, and then maybe even something even farther down in production when we're doing more microservices and other things, and we're building packages in production as infrastructure as code, and we're bringing in other people's code. So I don't think anybody has a handle on all the ways code gets into their organization and gets executed. So that's probably, for me, one of the most basic activities, is to get that down.
And one of the big reasons why that matters is that, well, you don't know how the code that came into your organization was tested in the first place. So you might be in a world where you're highly regulated. Maybe you have to go through a PCI audit every so often, or you're managing healthcare data, but the libraries that you're using, they were never designed to process that type of data. They were designed around this generic data. I've just got data, and I'm going to process data all day long. And some of the engineering teams I've worked with, we just refer to that as data. It's stuff. And if you've got this generic pile of stuff, well, how well tested was it to your security targets and your security obligations? Mm-hmm. Well, that's one of the big things that is a gap for most organizations.
Yeah, Tim, I've heard you talk recently in the past about how dependencies, the dependency rabbit holes or whatever, the number of levels, one single app that looks like it has 8 dependencies could have more than 100.
Exactly.
Is that the kind of thing we're talking about here?
That's exactly the kind of thing we're talking about. And you might be in a scenario where you don't know where things came from. So I'd say, like, one of the first steps for any organization is to figure out, number one, what you've got, because at some point, whatever you've got is something that's going to need to be patched. And if you don't know where the code came from, you probably don't know where the patch came from. And God love you, but if you go out to the internet and you say, find patch for widget A, you're probably going to be finding the first thing that said, I have a patch for widget A, which could very easily be something that includes code you never wanted to have in the first place.
It sounds like you just at least started to answer my next question, which was, how should teams get started with software supply chain risk management? Yes?
Yes, and it really comes down to something very fundamental. You can't possibly patch something that you didn't know you had. And I've kind of said that for years. I've shouted it from the hilltops, and yet we still hear people going and saying, well, I didn't know that this patch was available. I didn't know how this patch was going to come to me. Right. And the reality of the situation is most patch management strategies were designed around the paradigm of, I'm buying software. I have a relationship with a vendor. Not, hey, I can go download this piece of kit off the internet that solves all of my problems. I can go get this Docker container that does what I need it to do. And in reality, how patches are communicated in those scenarios really does vary. And if you don't know how the update mechanism works, chances are you're not updating it. It's that simple. If it's more complicated than your tools were designed to handle, you're probably not doing it. And that's one of the big risks when you're trying to figure out what your actual supply chain looks like. If you don't know where it came from, you can't patch it. If you didn't know where the patch should have originated from, you probably don't know how the patches are being communicated in the first place.
Mm-hmm. Great. Sammy, anything to add to that?
Sure. If you've never heard Tim shout this from the mountaintops, it sounds like open source, and then you take a throat lozenge. I think Tim gave a great answer that's more bottom up than top down. So I'll go ahead and give the top down answer. Top down, those 7 dependencies that were actually 100 dependencies are actually available from 5,000 locations. And so which locations am I allowed to get open source from? How long am I allowed to let it go with a known CVE of a certain severity? Where can I put it once I download it into my organization? Do I have a specific repository for it? Can people build with local open source, or must they build from some centralized, open source repository? How often, where? And so all this governance around open source is, again, from a top-down perspective, just as much a way you get started with open source risk management as the bottom-up perspective of, if you don't know it exists, then you're not going to do a very good job of managing its risk.
Exactly.
And I'll actually put a challenge out there for everyone. Go home, take a look at all of the devices that are powering your house that are dependent upon, that you depend upon each day, and ask yourself, how many different versions of OpenSSL are there in my house? And how would I patch it if I needed to?
Right. Yeah, I mean, this sounds unbelievably complex. And so, Sammy, at a practical level, how can teams enable consistent security controls and governance in all this complexity without slowing down innovation and development?
Well, so I'm going to answer that 2 slightly different ways. First of all, for the security team to not slow down the development team, the security team has to pre-make some decisions that the development team is going to run into later. So, for example, as Tim just said, OpenSSL, which version are we going to use and where are we going to get it from? If we wait to make that decision an hour after the development team needed it, then they will have already picked one and moved on. Nobody's got time for that.
Right.
So what are we going to need? So where does that come from? So maybe non-functional security requirements. So maybe we need to start leaning on our product management organizations to tell us far enough ahead of time what we expect from our IoT products, just as an example, what the marketplace expects, what compliance expects, so that we can start getting ahead of some of these decisions so that we can have these consistent controls. And then the second part, how do we make them consistent? Well, unfortunately, if we rely on humans to make these decisions each time, especially risk management decisions, something humans are notoriously bad at, then we're going to have to put them in code. So how do I pre-make as many risk management decisions as possible? And then how do I start my digital transformation and convert them into governance as code, guardrails, et cetera? That's how I'm going to get ahead as quickly as possible. And that's how I'm going to stay ahead, because those decisions are somewhat transparent, they're repeatable, the organization can examine them, we can tell when they're making the wrong decisions, we just change the decision, we don't have to change the entire set of people and culture. So some digital transformation and some, getting rid of this nonsense that we fell into in development over the last 10 years of code first, design never. Yeah, that's nonsense. That's for children. So we're going to start at least designing at the non-functional level, writing code, and then we'll go into our tight loop of build, test, build, test.
Tim, anything to add?
No, I think Sammy really hit it on the head. The process that we have today around a very iterative, hey, we can fail fast, we can just kind of prototype to production. That's something that needs to go and be re-examined when you're looking at the security of a supply chain, because if you're moving that quickly, you might not be in a position where you recognize that, hey, the entire development energy of some core library that you're dependent upon just moved someplace else, and they have different priorities than what you originally had.